Welcome to 9.2, Angles and Their Measures. Within this section, we are going to be taking a look at how to determine an angle, how to draw those angles properly, as well as how to determine the measures, not only as degrees, but also as radians. In slide 2, we first begin with understanding how to go ahead and draw out an angle. Now, every angle that we draw has two things. It has an initial side and it has a terminal side. Your initial side is known as your start, and your terminal side is known as your end. So, understanding where you are starting from will allow you to understand whether you are working with a positive or a negative angle. As you can see within this graph, we have our 4 quadrants. Quadrant 1 in the top right, 2 in the top left, 3 in the bottom left, and 4 in the bottom right. If we have an initial line at 0, notice as we go up, we would be going towards that terminal side. Now, wherever you decide for that terminal side to end would be where that degree would finish. Now, in this case, we see a 45-degree angle, roughly. And at this point, you can see that it stops. We identify it going towards a positive angle due to the arrow that's on the inside. Another way to draw this angle would be from the outside. Now, this would generally be a negative angle. And we'll go a little bit further into this within our next slide, in slide 3. In slide 3, we go ahead and talk about positive and negative measures. So we'll start off on the left-hand side. Keep in mind our initial side would be our 0. We go up to the top, which would be 90 degrees, 180 on the left, 270 at the bottom, and 360 would be once we've made a full revolution all the way through each one of our quadrants and back to the initial side that you started with. This angle here, because we are going up into our first quadrant, this would be a positive angle. Now, this is different than a negative measure, in which, yes, your initial side is still 0, but as we begin to go down towards quadrant 4, this would be a negative 90 degrees, negative 180, negative 270, and once again, negative 360. This is extremely important because the direction in which you have your initial side and the direction that it goes in will determine whether it is a positive or a negative degree or radian that you are referencing. In slide 4, we go into the naming of our different angles. So there are different ways of naming our angles. First would be using traditional letters from the English alphabet, A, B, and C. But you also have Greek letters that you could use, such as alpha, beta, and theta. Now, generally, in most cases, you are going to see the symbol for theta being used to describe an angle. The only time that you're going to see A, B, C, or alpha and beta being used is generally when you're referring to more than one angle at a specific time. Let's go ahead and take a look at slide 5. Now, we understand that there are 4 quadrants within our graph, but it is also possible for us to land on the x-axis or on the y-axis. Landing on your 0, 90, 180, 270, 360, and so on are called quadrantal angles. Now this would be whenever it lands on any one of the angles created by the x and y intercepts. So whether it is the 0, 90, 180, 270, 360, and so on and so forth. We have a couple examples that we can go ahead and work. Now keep in mind, as we look at this first example, we are trying to determine what quadrant it would fall within. Notice it is a positive angle because it is going up through the first quadrant and into the second quadrant. Notice third would be bottom left and fourth would be bottom right. So knowing that it is a positive angle, we would go ahead and identify it as falling in quadrant 2. For example, B. Once again, our quadrants are in the exact same place, but due to the fact that our initial line is at the 0 and we are going down into the fourth quadrant, this means that this would be a negative measure. Now, this would be in the fourth quadrant. Remember, this would be 1 in the top right, 2 in the top left, 3 on the bottom left, and 4 on the bottom right. As we take a look at our last example, notice this is a positive measure. In this case, we are looking at quadrant 1, 2, 3, and 4. Keep in mind, due to the fact that the line initially starts at the 0, goes up through 1, 2, and stops at quadrant 3, or between quadrant 3 and 4, stopping at the 270 degree mark, this would be a quadrantal angle. Now, even if we were to go ahead and say this angle would be a negative 90 degree angle, this would still be a quadrantal angle. It does not have to necessarily be positive. It just has to be a multiple of 90, 180, 270, 360, so on and so forth, whether it is positive or whether it is negative. Let's go ahead and take a look at slide 6. In slide 6, we have sample problems for us to work on to help go over how to find the quadrant as well as how to sketch it out. We'll go ahead and start off with angle 50. Now keep in mind this is less than 90, or it is between 0 to 90, which in this case would be quadrant 1. As we go ahead and sketch this out, we draw our two axi, our x and y. 50 would be just about there. And remember, as we're drawing, we want to make sure that we have the arrow showing the proper direction and where that initial line is and where our terminal line is. Negative 75, notice that is between 0 and negative 90. In this case, this would be quadrant 4. So as we draw our lines, keep in mind, negative 75 would be right here. Let's look at our next number. Our next number would be 180 degrees. Now this would be a quadrantal angle. And if you were going ahead and drawing this out, this would be from our initial side and stopping at 180. Now notice this is a positive 180, so it should be up and to the left as such. 208, keep in mind this is between 180, and 270, which means this would be in our third quadrant. As we draw this out, this would be from the first through the first through the second. And notice we're at 208, so it would fall somewhere just about here. Last would be negative 194. Keep in mind, in this case, this would be between negative 180 and negative 270. This would be quadrant 2. Keep in mind our axis on the x, we would start our initial at 0. We pass the 90, the negative 90, we pass the negative 180, and we come up to 194. You always want to do your best to try to represent that measure in the best and most accurate way possible. Let's go ahead and take a look at slide 7. In slide 7, we go over the definition of a radian. So a radian is basically a central angle of a circle that has a measure of 1 radian if it intercepts an arc with the same length as that radius. And that's extremely important to start understanding a specific length of the radius is matching up to that arc. In slide 8, we start going over conversions. Now these conversions are done between degrees and radians. Most important thing is to understand that the conversion itself is 180 degrees is equal to 1 radian. So as we go ahead and go converting from radians to degrees, we would use 180 over pi radians. And if we were going ahead and working with our second conversion, that would convert degrees to radians, which means we would multiply by pi over 180. The most important thing to realize and understand here is the fact that when we work on any form of conversion and we're dealing with degree and radians, it will always be a pi over 180 or 180 over pi. In slide 9, we're going to go over a couple questions to get a better feel for what this type of problem would look like. The first thing to understand is, what is the question asking us? So we are starting off with our first question, which is in degrees. And from that degree, we are going to radians. So anytime that we start a problem, we always start off with what is being given. And in this case, it's going to be 135 degrees. And that would go over 1. Remember, our units have to cancel. So degrees would cancel with degrees on the bottom. And that would mean that we would have to go towards pi on the top. What is the number of degrees within our conversion? 180 degrees. This would give us 135 pi over 180. Keep in mind, the degree and degree will cancel off. Pi is what is left over. Once we have 135 pi over 180, notice the 135 and 180 would simplify to 27 pi over 36. Also, 27 and 36, if you're not 100% sure of what it can simplify down to, you can always divide by 3. Most importantly, you can also divide by 9. to make it as easy of a simplifying process as possible. If we were to divide by 3, this would give us 9 pi over 12, which would also give us 3 pi over 4. In the case of our next problem for B, notice here we are starting off with radians and we are going towards our degree. We start off with what is given, which is 7 pi over 6, and we're going to multiply that. Keep in mind, pi must cancel with pi on the bottom, and our 180 degrees must go on the top. We simplify this out. 6 and 180 simplify to 1 and 30. 7 times 30 is 210. Now, also remember that pi from the top left will cancel with pi in the denominator. Only thing that is left is the degree sign. Let's go ahead and take a look at slide 10. In slide 10, we start to cover the various families that we have within our unit circle. So we have a 30, 45, 60 family, as well as the quadrantal family. We're going to begin with looking at the quadrantal family. It's very easy to understand. 0 degrees would give us 0 radians. Pi over 2. Now keep in mind, in general, and most important thing is understanding that pi is equal to 180 degrees. So when we refer to pi over 2, that is 180 over 2, or 90 degrees. And if we were looking at 2 pi, 2 times 180 would be 360 degrees. Now, if we have pi, which is 180, and 2 pi, which is 360, the middle between that would be 3 pi over 2. Now, be sure to make sure that as you're working on this test, you're going ahead and understanding that all of the radians will always be given in fraction form. Let's go ahead and look at our 30 family. Now, with a 30 family, we can always see that every single one of the radians is divided by 6. One of the easiest ways to understand this is that if we have a number like 180 and we divide it by 6, it would give us the degree of the family. So in this case, our 30 family would have a denominator of 6. As we start working with our 30-degree measurement, what we can always do is go ahead and draw out our graph. We know that we have 0, or this can also be 12 pi over 6. We know that this would be 6 pi over 6. This would have to be 3 pi over 6. And this would be 9 pi over 6. In this case, due to us having 30, our initial line of pi over 6 and that would be 30 degrees. Now in the second case, where we would usually have a 2 pi over 6, keep in mind that would be our 60 degree family. 30 plus 30 is 60. Now there might be an overlap to how this occurs. Even though this is 60 degrees, we would usually not put that within our 30 family. We would have it as part of our 60 family. And we can continue drawing this as we go around our unit circle. Notice 3 pi over 6 would be 90. 120 would be a multiple of 60. But if we continue going, this would give us 4 pi out of 6. We would also have 5 pi over 6 as we come around. Now, this right here would be 7 pi over 6. 8 pi over 6. 9 pi would be the 270. We have 10 pi over 6 and 11 pi over 6. That right there would give us our 30 family. So as we're going ahead and writing out 30 degrees, we should also be very familiar with their radians. So this would be pi over 6. Understanding that 5 pi over 6 on the radian side, if it was 6 pi over 6, at that point that would be 180. So we subtract 30 minus 80, or 180. And as we do that, we end up with a total of 150 degrees. We go ahead and look at 210. If we know that 6 pi over 6 is 180, we can add 1 pi over 6, which would leave us with 7 pi over 6 on the radian side. Our last move would be 11 pi over 6. Keep in mind, if we have a denominator of 6, 12 pi over 6 would be 360. This would end up having to be 330 as our degree. Let's take a look at our 45 degree family. The same issue occurs here. Notice we draw our lines. In this case, 45 would be here, 135 here. Between our 120 and as we start looking closer to 240, as well as what it would look like as we come across into that fourth quadrant. So initially this would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Our 45 degree angle would be pi over 4. 3 pi over 4 would be a total of correction. From our 45, we would go 3 pi over 4, which would give us 4590 up to 135. We then look at 225. Notice 225 would be past that 180, but before 270, which would be 5 pi over 4. And to be looking at 7 pi over 4 would be the same as 315 degrees. If you're doubting what the denominator would be, keep in mind, as long as you know the family that you're in, you can always divide that number by either the degree of 60, 45, or 30. That right there will give us the denominator of our problem. So if we divide 180 divided by 60, our denominator here would be 3. So this would be 1 pi over 3. As we look at 2 pi, we have our 60. 60 times 2 would be 120 pi. 240 would be 4 pi over 3. And 5 pi over 3 would be a total of 300. Keep in mind, if we were drawing this out, this would look very, very similar to what we were working on before with our 30 family. So in this case, pi over 3 2 pi over 3 4 pi over 3 and 5 pi over 3. Let's go ahead, work on slide 11, and get some additional practice on these problems. We're going to be focusing on what quadrant it is within and sketching that graph. So in this case, we have pi over 3. Keep in mind, if you're working with a denominator of 3, only family that would belong to could be the 60-degree family. So in this case, pi over 3 would be the same as pi being 180 divided by 3, which is 60. In this case, it's going to stay in quadrant 1. And if we were graphing this, this is what it would look like. Always keep in mind that you can use your pi to help you solve your problems. If you know that pi is 180, if you use the same number as in the denominator, they will cancel each other off and you're left with 180. Let's do that same scenario, but with a second problem. Now notice we do not have a denominator of 12, but what we do know is that as we draw this out, this 180 mark would have to be 12 pi over 12. This would have to be 6 pi over 12. 7 pi over 12 would fall into the second quadrant. Let's take a look at our third problem, a negative 2 pi over 3. Keep in mind we will be having our initial line at 0, but we are going to go downward and towards that clockwise direction. As we do that, we can go ahead and use the same thoughts that we've used for our families of 3. That's going to be 60. 60 times 2 is 120. In this case, we would be in the third quadrant for this problem. As we work this problem, keep in mind, and we are drawing it, if we are looking at 2 pi over 3, that means that we are looking at a family of 60. 60 times 2 is 120, which would roughly give us a line here. Because it's negative, we go ahead and go downward until we hit that line. 5 pi over 6, keep in mind, that would be the equivalent of our 30-degree family. We go ahead, even if you're not 100% sure, you graph it out. This would be 6 pi over 6. This would be 3 pi over 6. So you know that 5 pi over 6 would be just about here. Now, if we know that we are within 30 degrees, 180 minus 30 would leave us with 150. 150 would be classified as quadrant 2. And lastly, we have pi over 3. With pi over 3, we know that it's part of the 60 family. So in this case, our terminating line would be on the 60 itself. And notice that would be quadrant 4. So arc length formula, it's always going to be measured in radians. And that will happen every single time. Now, this is where it's extremely important to pay attention to the small details. Keep in mind, this is our equation. S is equal to R times theta. Now, in this case, R would stand for your radius, and S would be our sine. In slide 13, it says find the length of an arc intercepted by a central angle of 1/4 in a circle of radius at 3. So this would be very, very simple. We go ahead and S is equal to theta times R. So S is equal to 1/4 3. As we multiply, even if you have to go ahead and put this back as a fraction, once you do, this would be a 3 over 1. You multiply straight across. S is equal to 3 pi over 4. Keep in mind that with these problems, there will be times where you still have to end up putting their actual unit. So in this case, we are talking about 3 inches. So eventually, inches would have to be placed on the back end of our problem. Let's take a look at our second problem. It says find the perimeter of a 30-degree slice of a large 8-inch radius pizza. First thing, we know that if we're working with 30 degrees would be equal to, correction, degrees, not, so keep in mind, 30 degrees will always give us pi over 6. Now, as you work this problem, keep in mind, it must use pi over 6. You cannot use a decimal. So we go ahead, we set up our problem. S would be equal to theta R. So we go ahead. Your S would be equal to pi over 6. And that would be times the 8 over 1 that we had solved before. Now, once we start multiplying everything against each other, notice this would give us s is equal to 8 pi over 6, which simplifies to 4 pi over 3. Now keep in mind, inches will still be there because we are talking about an 8-inch radius pizza. Highly suggest you go ahead, work through these problems and the progress track itself. If you have any questions, please feel free to stop by.